Now, in this video we're going to be looking at circle properties and circle theorems. Let's look at the properties first. There's a circle, and the first property is to do with a chord. Chord is a line that crosses the centre. Anybody in the audience now can tell me, what does the line from the centre to the midpoint of the chord, what angle does that make? Audience members, what angle must be? So it's divided the chord exactly in two. What angle do you think that makes? 90 degrees, yeah. And the converse is also true. If you had a circle and a chord, there's the centre, and you knew that the line from the centre to the chord made an angle of 90 degrees, then it must cut the chord in half. Right, that's one basic property of circles and chords. Let's look at a second. I think this one's fairly intuitive. We've got a point outside the circle. We'll call it point T, and these two lines from T are tangents to the circle. If we call that A and that B, it should be fairly intuitive that the length AT equals BT. And one final one, I can demonstrate this on this diagram. What angle does the radius make with the tangent? GT, do you remember? No. 90 degrees, well done. So they're the circle properties. Now let's look at the theorems. Wonder how many of these have sunk in. Our first one, the major complication with these is the terminology. Here we have a chord, and on that chord, daisy, I've got black here, or blue, and we have standing on the chord, we have two lines making two angles. What can you tell me about angle X and angle Y? Well, angle X equals Y. They're the same angle, but the hard bit is writing down the reason, and this is the full reason. Angle subtended by same chord, or should be angles subtended by the same chord, are equal. Note, very often that chord isn't necessarily drawn in. So you may want to, if it helps you, if you see a diagram like that, draw in a chord, and then you'll be able to perhaps easier remember the angle subtended by the same. Angle subtended by same, look, I missed out the word chord. Are equal. Now there's one other fundamental theorem. It's to do with tending again. And of course, if we have a situation like this, there's the centre, and again we've got a chord, but this time one of the angles is subtended by the chord goes to the circumference, and the other angle subtended by that chord goes to the centre. What's the relationship between angles X and Y? Well, you can probably guess this now. Angle Y is bigger. In fact, there's quite a neat relationship. Angle Y is twice angle X. And let's write that angle at centre is twice angle at circumference. That could probably get you the reason marks. Obviously, if you want to be really precise and complete, we would say if subtended by same chord. Now, from that it follows, as you'll see, that if that chord is the diameter then the angle at the circumference, which remember is half, an alternative way of looking at it, is half the angle at the centre, must be 90 degrees. Let's go in detail as to why. Because the angle here is a straight line, so it's 180 degrees, and if I use blue, you can see that this angle here, subtended by that red chord, okay, the centre must be 180, because it's the diameter as well, and therefore this angle must be half of that, 90. But the way we write it down, the reason giving is this. Angle, it's a bit easier and quicker to write. Angle in a semicircle, angles in a semicircle are 90 degrees. Right, let's pause there. Right, there's two more theorems to go through. These seem to be ones that are most regularly forgotten. This one here involves a quadrilateral in which all four vertices of the quadrilateral lie on the circumference of the circle. And the theorem is this: that opposite angles add up to 180. So, how do we write that in the exam? We're asked to give the reason. It is opposite angles. You must put the next bit in a cyclic quadrilateral add up to 180 degrees. Now the last theorem, sorry it's gone on a bit, is this one here. I wonder if you can guess what it is. There's an angle formed by a chord and a tangent, and here's an angle that stands on the chord in the other segment. What's the relationship between x and y? Well, the answer is they're equal, and this one has the briefest of reasons. It's alternate segment theorem. Segments, remember, are a chord divides a circle into two segments. There's segment A, and there's segment B. Okay, I'll try and keep this, I've been endeavouring to keep this brief, so I won't go into how we use it. I'll look at that in my next video.